Here's the displaced terrain that we made last week, along with its water. We also have USD output enabled or disabled, so I can turn that on. And I'll get what the USD is outputting, turn that off, and I'll get what Maya is outputting. And this is what we're going to use to scatter on a terrain or on a surface. So before we do anything, I've got this whole compound made up here, ready to go that we did. I'm going to make a new one, so new graph. And let's call this, let's rename this graph by double clicking here and going low res forest scatter. I don't need this guy. I can hide him. I don't need to see it. Now I've got a nice blank empty graph, and here's something else you can do. Just like bringing in meshes or whatever, you can middle click on a Bifrost graph and drop it in there. Comes in with field shape. I hook that up to the output. This is that entire graph coming through. A couple of things you have to be wary of. I have an array here of two things. What are those things? Well, they are the output. So again, we just need to change the port type. So we set the port type. All I'm going to do is take the array off. There's the first one. That's the water plane. So for speed and ease of use, all I'm going to do is separate this out. Because there's only two in the array, there's my first in the array, I can also go last in array. Handy, handy things, especially when you've only got two things in your array. Let's put that up as well. And that's my terrain. What this means is I can delete these outputs, put down a terminal, and there you go. I've just got my terrain. I can, for example, plug that into proxy, and that gives me the ability to look at it or not, as the case may be. Now, let's scatter on this, just like we did before. Grab here, and we're going to scatter the points. I would quite like to see those points, so point scope, just as we did before. That goes in there, and we can just pop this out to the diagnostic to see the points. And there we are. We have scattered points on this surface. If I jump back into here and just turn on my USD, turn that to true. What I wanted to illustrate with that is that this is still connected to this. And we're not actually scattering on the USD. We're scattering on the terrain object because we're not actually looking at Bifrost anymore. We're looking at Maya USD, which is what Bifrost outputs to when we switch that output here to USD. Really what's happening inside this new graph is that there is nothing coming through here at all. Check that, nothing in that array. Nothing in that array either, same array, not surprised. So that means there is nothing coming through here. I've got no information. I've got no information here because we're not outputting that anymore from the old one. So that's just something to be careful about, but we'll turn that back to false. And you can see immediately I get the terrain back and I get all of the points I scattered. Perfect. So just remember, when you bring another Bifrost graph into another graph, it's still connected. Things you do on the first graph still affect the second graph. We're good to go. I'm going to hide the USD proxy because we don't need to see it right now. And we're just going to work on this guy. One thing I will do though, is I might change the way that this is shaded. At the moment, it's just shaded by assigned diagnostic material, which is great to show the lerp and all that sort of thing. But I actually want to start to see the normals now because it gives me a better sense of scale for my trees. So I'm going to change the way that this is shaded. I'm going to do it by putting pass down so I can start to split my data. And I'm going to assign a material instead, which is fine. We'll pop that up into there. And let's put down an if statement so we can switch between the two things. Right now, we want that in the false case. And we want to pop that into the true case and then turn that on. So you can see now that even with the default material, I can start to see what my what these hills look like. I can start to see more details. Now I want to get the color on. That's fine. All I need to do is put in a standard surface material, which is what the default material is. If I plug this in to the surface material, the color changes a little bit. And that's because this has specular, the default one doesn't. And all I'd need to do is plug that into my base color, and it's not going to be happy because it doesn't take an array. So if you remember in here, set geoproperty reference, we did a little bit of that last week. Set geoproperty reference. What this allows us to do is to tell my material, hey, I've already got color on this mesh. I'd like you to use it, please. And the way it does that is, if I put this in between the standard surface material and the surface material, like this, and I've got two things here. I've got a geo property and I've got a material property. We know about geo properties. They're the per point properties on our Bifrost objects. So if we look at this and get some stuff out of the way, face normal is a geo property, face vertex is a geo property, point normal, point position, all of those things. Anything per point is a geo property. So I need to add another geo property into this guy before it goes into assign material. So let's go set geo prop. All good. That property is going to be point color, which we use for point color. In this particular instance, we could call this anything we like, but we're not going to, because point color is a good standard to get used to. What I'm going to do is make a value node out of that property. You can see it makes a string with point color in it. I'm going to plug that into my geo property. So that's the property on the geometry that you would like this to pick up. Material property is the property on the surface that you would like to put these values to. In our case, we need base color. Just like that. Nothing much changes because we actually haven't given it anything yet. There's no data coming in. The data we want to use is this lip. And there we go. So this is very much like this guy. Because I'm using a material, I'm able to see shading, lighting, that kind of stuff. I'm able to use the normals on the terrain to see features on the terrain. You can even see a specular highlight there. And I do this because it gives me a much better sense of scale, because that's what I'll be scattering today is trees. Okay, so we need to do some setup for this because obviously we're still in the field shape, which is fine. That's cool. We should probably like set up our coloring so that we can happily switch this without having to dive into 16 different things. So what I'm going to do is on here, I'm just going to put use material. That way, if use material is on, I get the material I set up. If it's off, I'm just going to get the diagnostic material. It's exactly what I want. Go back to here. And now we can start working our scatter. Couple of things here. I would really not like to scatter things on the top of the mountains, because trees don't grow very well on the top of the mountains. I would also not like to scatter things right in the middle of the lake. So this is the first thing we're going to do is we're going to take our water plane and we're going to make sure that anything below that water plane does not get points on it. And that's fairly easy to do. So for here, we just go to get point position. So I'm going to get the point position and then I'm going to get the Y position. Now, the thing is with this water plane here, so if I get the Y value of whatever that is, and I'm pretty sure that Y value is 0, minus 0.02. That's the level my lake's at in terms of up and down in the sea, 0.02. The plane itself, if I select this, you can see that the plane itself, it's quite dense and it's quite heavy, but it doesn't have any displacement on it. It's just a flat plane. What I want to be able to do is say, look, you know, if we need to do it on the thing we're scattering on, which is the terrain. I'm going to say, look, if you're equal or less than this, then you have 0 weight. You have nothing. You do not scatter points there. What we're going to do now is construct some more complicated weights to do our scatter on. And this is the first one. So if I take this, and because I know this plane is flat, I can just take one value. I can take the first value in the array because they'll be the same values no matter what point I look at. Really all I need is the first value, and that's the Y position of the first point in that array. So I can take this and do the same as up there, so I get point position. Vector to scalar. So what I'm doing is I'm splitting the vector values out to their components, and I can say, okay, less or equal. So if any of these Y positions are less or equal to this, and that will give us a true or false array. That array will be the same number as it is here, which makes it useful to us. This is going to become our weights to start with. If I put down an if statement and I make this floats are fine. And I plug this in here. If you're true, I want you to be 0 because less than or equal to this plane. So if it's the same as this plane or less than the plane, this will return 0. If it isn't true, if it's greater than the y value of this plane, I want it to return 1. So it scatters all my points. So let's get a view where we can actually see through. If I hook this up to my density weights, they're gone. So there is nothing underneath this water plane that's getting scattered on. See? Those look like they are, but they're actually being scattered on top, on here. So that's the first thing we're going to do to our weights, and this becomes our weights array. Right now, all this array is 0 and 1. So nothing or full. And we can demonstrate this by going back to our scatter by number. Let's add a 0 to that. So we get 10,000 points. And if I hide my water plane, you can absolutely see that that's working. So that's our first condition for our scatter. We didn't want anything, any trees in the water. Let's take this point scope and let's just make these guys teensy bit smaller. Because right now I'm going to go in here to my scatter again, and I'm going to add another 0 to this guy. So we're now scattering 100,000 points. Nice and fast. It's obeying its weights. It's doing what I want it to do. There are some other rules that I want to take care of here with our scatter. The first thing I want to do is make sure that we don't scatter too high either. These guys look like mountains to me, or at least rocks sticking up out of the ground, right? Given the scale that we're using, I'm going to say they're mountains, but also given the scale that we're using, what will come out of this is a stylized low poly forest, not a realistic one. But we can still use a lot of this. So what I'm going to do now is exactly the same thing as this. I'm going to get the Y position of these guys, which I already have here. And I'm going to say, hey, guys, are you greater than something? And what's that something? That something is a value that we can put in. I go to my right view and I turn on my grid. You can see that most of my Y values here sort of go from about 0, which is this line here, to just over 1. Just over 1. So let's say, to start with, until we get this right, we'll go 0.5. So now we're left with the problem of going like, okay, so I've got 2 arrays here. They're both putting out Booleans. How do I make sure that this works? Well, there's 2 ways to do this, and I'll show you both. The first way is Boolean logic. So what I'm basically saying here is that if I'm less than or equal to this number and greater than this number, I don't want a point to be there. I don't want to scatter it. So we can put in an AND here. So what an AND does is an AND is only true if both of these are true. So this immediately won't work because you can't be less than or equal to one number and greater than another one if those 2 numbers aren't in the same place. What we're looking for here is an OR, but I wanted to show you AND. So if I am less than or equal to, in this case, the water level, or I am greater than some number we're going to put in, I don't want to scatter, same deal. Boolean logic. And because this is set up to say, okay, look, if you're true, die, then all I've got to do is plug this in here, and I've lost all of my points on top and my points on the bottom. So now you can see we've got all these naked hills poking up out of here. And that's 2 conditions that we've put onto our scatter and into our weights that is enabling us to not scatter where we don't want it. We don't want it too high. We don't want it too low. So and I mean, this is the most basic thing. I can bring that down and down and down until I've got something like that. I could go ahead and just use this as my scatter. I'd have nothing in the foothills. I'd have nothing like that. That would be fine. At this point in time, it's absolutely warranted to go in here and put that 0 back. So you get a better view of it. And you can see that I've got a very narrow range where I'm scattering. There's no scattering below this number. There's no scattering above that number. Perfect. It's great. But for one thing, if you have a look at around the edges of the lakes, you remember we set up that softness? We got some hella steep hills here, like almost cliffs that I really don't want trees on, because when something's a bit too steep, then you're either going to grow a tree like coming out of a cliffside, which you could put in if you wanted to. But in our case, not going to do it. We'll just do it because this is an example. We're going to do a little bit of math to calculate the steepness, and for that, we're going to use the normals. So basically what we're going to do is compare the normals of these points. And if you remember, these are picking up the normals from the surface that they're being scattered on. So obviously I can't get the normals of these points and then do things with them before I've scattered the points, right? That will cause a loop, but that's okay because I can base it on the point normals of this terrain. If we have a look at the terrain, you see there's quite a few normals here. So let's deselect that. And I'm going to need to get the point normals. Before that, what I'm able to do here, just to show you what I'm doing, I'm going to leave this, I'm going to take this point scope off for a second. These will just turn into points. They are still there. They're just very, very small. Zoom back, you can see it there. They're grey and they're small, but they're still there. So I'm going to use a function of point scope to have a look at our normals. And the way I'm going to do that is I'm going to copy that, paste it here. Copy, paste. Thank you. But I don't want to look at the scatter points anymore. I want to look at the terrain mesh. I want to see all the point positions of the terrain mesh, which is fine. Let's pop that in up there. So this is just showing me all of the point positions. Point scope has this cool thing called enable arrows, which will draw an arrow of a vector property for you. Change it to point normal, switch on the arrows. And you've suddenly got a whole bunch of arrows because there's quite a few points in that mesh, which is great. I can change the length of those arrows like this so I can see the angle of the normals. Fabulous. That's exactly what I want. Why do I want to see the angle of the normals? Well, because I'm going to take that angle and I'm going to compare it with another angle using a dot product, which will allow me to not scatter on anything too steep. What a dot product will give you will tell you how similar the angles are. Not going to get into vector math. I'm kind of assuming you already have some. I can do the same here, by the way. I can show you the normals of these guys by just doing the same thing. Turn that to point normal and turn that on. And this is giving me the normals of the underlying mesh that have been sampled onto these points. Just a little point scope help, but what we're going to basically do is take a vector that is straight up and down. So let's make a vector. We just need one because we're going to compare all of these to one. Now watch out for that. If you've got something selected and you make a new node, Bifrost wants to connect it all up. I don't want that. What I actually want to do is get a normal 3-point vector. There we go. This is going to be our up vector, so vector 0, 1, 0. Then I'm going to get these point normals here that I got before, and this is where I do my comparison. So if I do a dot product, I'm going to compare this, well, I'm going to put this vector into the first and these vectors into the second, and I'm going to get a value out of here. Now, even if you don't know how a dot product works, and I'm kind of playing this like we don't, I do, but the easiest way is how similar are the two vectors. Let's look at this to see what kind of results we're getting out of here. And the way we've been doing that is I can just assign it to the terrain as a diagnostic material. Let's just change the terrain to that. And that's going to give me the dot product value. Now they're pretty bright. They're pretty bright because these guys are going from 0.2 to 1. This is what we're going to do our steepness calculations on. But you can see that it's white where it's flat, and it gets darker and darker and darker depending on how steep it is. But now we have essentially something that measures how similar the point normal is to a vector that just goes straight up and down. What this is basically telling me is that the whiter it is, the closer to 1, the more similar it is, and the darker it gets, the less similar it is, which means that I want this value to be above a certain value. And staying with the Boolean, oh no, we did Boolean logic last time. You could do this with just an or. So at this point, you want to go, okay, I need you to be above a certain value before you scatter. Cool. I need you to be greater than. I need you to be greater than a number, some number, let's just say 0.5 to start with, and we can dial it in later. And then we just put in another or. So if that's true, or this is true, then do some culling. Okay. This is pretty simply means I got that round the wrong way. So you can see that it's just kept the really steep stuff. Easy to fix. That greater should be a less. So we plug that in there. We make that 0.5. We replace that one with that one. And suddenly we are scattering by steepness. So because I've got control of this, if I pull this up, I can literally choose my threshold right here until I get what I want. So at this point in time, I'm getting to the point where I'm quite happy for this to be my trees. So you can dial that in to any range you like, but I'm going to go to something like that, just eyeballing it. So now we're quite happily, we can just take the diagnostic off, get our colors back. And you can see we're no longer scattering on these really steep slopes. We're not scattering above a certain point. And that's just using Boolean logic. So it's, is it this or this or this? Just for completeness, I'm now going to show you how to do it literally on the array itself. What we have here is an array of zeros and ones based on what's coming through. Luckily, my true or false is also a 0 to 1 array, which is how I can do all the Boolean logic. I don't want to do Boolean logic right now. What I want to do is find all of the true. Everything in that array that is true. All right? And remember that this is reversed. It's killing things that are above a certain. So these guys get true, which means instead of going through the if statement, which we did before, I have a new method. So I can go set in array. So this is going to say, all right, at these values in the array, set it to this value. Well, these are all my true values in the array. And I want to take you. Let's just get that or out so we can see if it changes. There we go. So I want to take you and I want to set you to 0. All of the ones that match these indices. And if I plug that in, you can see all of the steep stuff disappeared. So it's essentially doing the same thing. First one by Boolean logic. So is it less than equal to this number? Is it greater than this number? Or is it less than this number? If all of those are true, then die. Not going to scatter there. Otherwise, I am going to scatter there. It's a binary thing. Whereas this one is saying, okay, I've already made one decision. This is an array of zeros and ones. I'm finding all of the things in here that are true, which are these indices. And if we take a look at these, so this is 21,000 indices long. The minimum index is 39. The maximum is 90,511. So it's saying take everything at these particular indices, and set it to 0. And it's doing the same thing. So that's a little bit more of an advanced weights calculation for scattering. But we're essentially going nothing less than that, nothing greater than that, nothing steeper than that. You can very much extend this and say, okay, maybe I've painted some things on the map, so I want nothing in these areas. Plug that into. Maybe I've calculated rivers and moisture runoff. Nothing there, please. So that's how that works. We're about ready to start putting geometry on this scatter.